So here comes the part where they switch it all around on you. You've learned the basic straightforward stuff, and now you're going to have to figure things out backwards. Rather than giving you the angle and saying, okay, plot your sine, cos and tan ratios, they're going to say, here is cos, find the angle, or angles, where it's possible. So basically they've given us these parameters, which means that we can go from this 0 degrees all the way around to 360 degrees, but we're not going to go to 720 degrees, and we're not going backwards. So we can kind of mark down 0 degrees. 0 degrees is here, so is 360. So basically we've got one full circle to work within, and what we're being told is that cosine is negative 3 over 4. So probably the best thing that we can do for ourselves is remind us what cos is. Cos of any angle is x over r. R is never negative because it's the result of Pythagoras. That means we must have a negative value for cosine, so a negative value for x. X is negative in quadrant 3 and quadrant 4. Whoops, this is 2 and 3. Quadrant 2 and quadrant 3, because x is negative here, cos will be negative here, which means that our angles are going to be here and here. Now, we don't know what the reference angle is, so we can just roughly sketch it in and go, this is x, that's r. One, two, three. And it doesn't really matter what the y part is for now. So it's either going to be somewhere around here-ish or somewhere around here-ish. So we can draw those little terminal arms out. Good enough. We know that this is 4. And we know that this is 3. Could be this one, could be this one. Now, I guess the first question is, do we need y? Do we need to find that? Well, the question is asking us to the nearest degree what values of theta satisfy this equation. We don't really need y because we have enough information to find theta. The first thing we need to do is solve what this little dude is going to be, and that's the reference angle. So I can use this. I can go second function cos of negative 3 over 4, because that's x over r, and I should get my angle. So I take my calculator, second function cos, negative 3 divided by 4, close bracket. Yeah, you know what? It's better to just go second function cos 3 divided by 4, because that will give me my reference angle. So if it was in this quadrant, then my reference angle would be 41.4. And I don't really love to round that off because it's so close to halfway. So I'll just leave it for now. Okay, so I know that this is 41.4. I know that's 41.4. I know that this is the relevant point and this is the relevant point. I don't actually need to find out the points. I just need to find out this and this. So given that 41.4 is my, fine, we'll just go 41. Given that 41 is my reference angle and I'm in quadrant 2 for this one, let's use a different color. Then I'm going to 180, but I'm 41 short of 180, so I'm going to go 180 minus 41, which gives me the angle for the green arrow. So we got 139. That makes sense. Now, this red one goes past 180, 41 degrees. So we're going to go 180 plus 41 to get it, gives us 221 degrees. So within the confines of 360 degrees, and knowing that cos is negative, so x has to be negative, which means that I'm stuck in quadrant 2 and quadrant 3, then I've set up my angles, figured out my reference angle, used the reference angle to determine how far that is, 139 degrees, and how far the red one is from standard position, which becomes 221 degrees here.